Hey everybody, this is Brian and welcome to the 118th Qt tutorial with C++ and GUI programming. A little bit of shameless advertising first. Be sure to visit my website voidrealms.com for source code for this tutorial and all the 117 other tutorials that I've done. Just go to tutorials and select the language. You're probably looking for Qt, right? And a little bit of shameless advertising. Visit pluginbot.net, my new side project, centralized device management. Whew. Now my friends will be happy because I've done my marketing. Now back to the stuff I enjoy doing. Alright, so what we're going to cover today is debugging. You see this beautiful bar on the left here, and through 118 tutorials we've managed to totally avoid this big bug icon. When you click it, you get all these weird windows. What in the heck? And what does all this stuff do? Well, we're going to explore this and find out. Alright, so I've got a very basic program here. Let's go back into edit mode. I've got a dialog with some buttons, and each one of these has a signal slot, so we can open that up. Some people ask why I don't just put the signals and slots right in the classes. Well, I don't want any voodoo magic, so to speak. I don't want anything hidden, so when somebody's brand new to this, they can come and just go, oh, that's how that works. So you can very easily see what happens when you push each button. So basically all we're doing is calling this class my class, which has some functions in it, like bad pointer. You guessed it, returns a bad pointer. So let's actually go here. This is a pretty common mistake I see people do. Q-scope pointer, and you're making a new Q string, and then you're returning the pointer. Well, what happens with the Q-scope pointer? It goes out of scope, and it deletes the pointer. But you're returning the pointer, therefore, boom, program crashes. Custom debug, we're going to cover this. It's just a for loop. And let's see here. What's that? Oh, I never used I. Variables, we're just going to talk about how to explore local variables and bad math, something that's also very common here. So let's just dig right in. If we run this program, tick tock, tick tock, tick tock, see we have this beautiful interface, and just to show that it dies, we're going to click bad pointer. And you see it does something for a second, and then boom, program has unexpectedly finished. If you've gone through 117 of my tutorials, you've probably had this at some point, and you've had to sit there and figure out what in the heck happened. Well, we're going to talk about how to fix all that. So, first things first, how do we launch debug mode? Well, you can either click debug and then click this little arrow with the bug next to it, or you can click this guy down here. Some of you may be wondering what's the difference between debug and release. Well, if you've compiled, you'll notice that debug, your executable or your binary, is significantly bigger than release. And that's because it adds what's called debug symbols, meaning it adds little bookmarks, if you will, into the code so it knows where it is, so it can figure out what happened. Release strips all that out, so it's lean, mean, and ready for production. So be sure you're in debug mode, otherwise I fear this may not work. Alright, so if you're in edit mode, and you click this little guy here, you notice how it instantly flips you into debug mode. That's the first thing you should notice. So let's talk about all these windows and what do they do. Let's actually kill the program here. We're going to add some debug, or I'm sorry, some breakpoints as they're called. So the first thing we're going to do is we're going to go down to variables, and we're just going to, on line 29, right click, and we're going to set breakpoint. Notice how there's suddenly a breakpoint here. It shows you the number. There's no real function name, but you can mouse over and get a whole ton of information about where you're at. Now, when we debug this again, click variables, boom, it stops. And you notice how suddenly we've got a ton of data, and you got a little arrow that tells you that's where we are in our code. So you've got all this information of where we are. We're in the myClassVariables function on line 29, and then you can see kind of like a trace of what happened. I think this is called the stack trace, kind of like breadcrumbs of where you were. Here is the breakpoint that was triggered, and these are the variables. You can see how we have I right here. Sometimes you can get it to work where you can mouse over and it'll give you the value. It says, it's 10. Name Brian, so like if you mouse over, locals, because you're at that debug point, is Brian Cairns, because we're saying name is Brian, name.append. So let's actually stop debugging, And we're going to add another breakpoint in here. So now we've got 2 breakpoints. What is a breakpoint? Think of it as if you're on the information superhighway and you see something really interesting and you want to hit the brakes and stop. That's what it does. It actually stops the execution of your program and gives you a chance to glimpse into the memory and see exactly what's going on under the hood. And you can see how we've got our number and our line. You notice how they're flipped around. You can sort those, I believe. We're going to debug again. Now, you can just press F5 on the keyboard to debug. And click Variables. Notice how we're at the first breakpoint. So it just says name is Brian. Also gives you the address to this. You can right click and you get a whole slew of options. You can actually use like raw pointers and just display it any old way you want. So how do we jump from this breakpoint to this breakpoint? Well, very simple. Click that button or just hit F5 to continue and it jumps to the next one. You see how it jumped from the first to the second? You also have stop. You have step over, step into, and step out of. And this little guy which switches the debugger into instruction-wise mode, which if you click that, you get this horrendous looking nightmare. It looks like ancient Egyptian algebra. That's actually assembly code. That's pretty much one step ahead of machine code. So that's about as close to bare metal as you're going to get. I personally do not know assembly code. I can kind of see a little bit of what it's doing just because I've been programming for so long, but I don't dare try to mess around with that just because I don't know it. So if you click that, just click it back and go here. If you step over, you're going to jump over QDebug. Notice how QDebug is a function. So if you step into, what happens? You actually step into the header file of the QDebug class, or actually the QLogging class, which holds the definitions for QDebug. So if you get lost in that, step right out and jump back out, and that's how you do that. And you can just continue, and it'll run your program. Click stop. We're going to do something a little more complex here. We're going to do a, let's do bad math here. We're going to set a breakpoint, and now we're going to actually disable that breakpoint. You can actually disable those. Isn't that pretty neat? Enable, disable. So if we disable that breakpoint, let's run this bad boy. Click on bad math. Look at that. Inferior stop because it received a signal from the operating system. Arithmetic exemption. So even with that disabled, let's actually just delete that. Do this again. Boom. See, you catch those really weird errors. Like if we were to just not debug this and just run it, do bad math, what happens? Boom. Program unexpectedly finished. And you're left scratching your head trying to figure out what just happened. Well, this is a division by 0 error. You can't divide by 0, obviously. But when you're in debug mode, it'll catch that, even if you don't have a breakpoint. Now, there's another way you can do that, which you can actually set a breakpoint, and then you can edit the breakpoint. And you notice how you get this breakpoint type, file name and line number. Well, you can set this to like function name, if it's a specific function name, if it's a memory address, or whenever a C++ exemption is thrown or caught, or a whole slew of other options. So we'll just say thrown. And then you can add conditions. You can ignore, so like a number of counts. So if you want to wait until it happens 102 times, then you can do that. Commands, tracepoint, and message, I believe that's for remote debugging. I've never actually gotten that to work. So we're just going to set our little invisible breakpoint there. And bad math, boom. Same deal. So pretty neat, huh? So we're going to delete that breakpoint. Actually, we're going to delete all these just so we can see what's going on here. All right, so far we learned to look at variables. Now we're going to make something a little more complex here. We're going to create a breakpoint on line 18, and then we're going to edit that breakpoint. Now, you see we're in a for loop, for I equals 0 to 10. So basically it's going to go from 0 to 9. So what we want to say here is condition. We want to know if I is a certain number. So if I equals 5, and it's going to use the I variable from your current scope of where that breakpoint is. And you can see over in your condition view, you've got the I equal 5. You can even select specific threads if you wanted to. So we're going to debug this thing. Custom debug. Now you can tell this worked because we're in the my class custom debug, our little breakpoints there. And what's the value of I? 5. Same thing as our condition over here. So that's one way of setting a breakpoint. So we're going to stop that. And let's see here, remove breakpoint. Last but certainly not least, we're going to go with a bad pointer. This is probably one of the most frustrating things to debug, especially if you're working with some legacy code where they don't really do any memory management. They just hand you a raw pointer and, well, there you go. And a lot of times if there's an error, they'll just say something like, you know, if error, then return 0. So you may get a 0 and you still think you're working with something. But in this case, scope pointer, remember when this goes out of scope, program's going to crash. So let's actually run this. Bad pointer. Boom. Program has unexpectedly finished. So how do we go about debugging that? Well, we can't debug it here because, well, it's still in scope. So we need to go to our other class that's actually calling it. Right here, bad pointer. So we got a couple different things here. You see how we're debugging, we're doing a qdebug, and we're spitting out the address? Well, because we got an address, we know it's not 0. It hasn't been deleted. So what's going on here? Well, let's create a breakpoint. Whoops, mouse is acting up a little bit. And let's create another one here. And we're going to edit this guy, and we're just going to say C++ exemptions thrown. And we're going to do bad pointer again. And you can see how we have a string. It's got a memory address. And boom, there's our segment fault. The inferior stopped because it received a signal from the operating system. Meaning the operating system says, I don't know what you're talking about. That pointer doesn't exist anymore. So it does what's called a segmentation fault. If you ever used, I think it was Windows 98, maybe even XP at some point, you get what's called the blue screen of death. That's pretty typical. But you also see what it highlighted for you. QStrings append function. And from there you can figure out, oh, well, I don't have a very good pointer. So then you can actually spit out the pointer and things of that nature. And you can see how it's actually highlighted right here. And it tells you, okay, here's your breadcrumbs. Metacall, static metacall, on the button push, string append. There you go. Let's step out of there. Whoops. So that, in a nutshell, is debugging. You can do many, many more things, and you can actually do some very cool things. Unfortunately, I don't think the breakpoints actually persist with the code. I will put the code out on my website, voidrealms.com, just so you can see exactly what I've done and play around with it a little bit more. This is horrendous programming. Don't ever do this, but this is just for demonstration purposes. All right. Thanks for watching. I hope you found this educational and entertaining.